Hello and welcome. Today, we're diving into a significant achievement in artificial intelligence from Google DeepMind.
Hey everyone, and welcome to The Explainer. Today we've got a really special one for you. It's a story about artificial intelligence doing something more than just learning a skill. It actually made a scientific discovery. We're talking about an AI that solved a math problem that has had the smartest people on the planet stumped for more than 50 years.
So let me just start with this question. What if a computer could find a solution to a problem that humans have been banging their heads against for half a century? This isn't some far-off sci-fi scenario. It's exactly what happened with DeepMind's AlphaTensor, an AI that has really forced us to rethink the limits of what computers can do.
Okay, so here's how we're going to break this all down. First, we'll talk about why any of this matters, what I'm calling the universal speed limit. Then we'll get into the weeds of what it means to multiply grids of numbers. After that, you'll see how this whole thing turns into a wild 3D puzzle. And of course, we'll introduce our AI player. Finally, we'll see it shatter that 50-year record and talk about what this means for, well, everything. Look, we all want our devices to be faster, right? But just making the computer chips faster and faster, well, there's a physical limit to that. The biggest leaps in speed often come from making the software smarter, improving the actual recipes, the algorithms that do the work. Finding a better recipe can make a bigger difference than any new piece of hardware. And believe it or not, one of the most important recipes in the entire digital world is something called matrix multiplication. It sounds a little academic, I know, but it is everywhere. It's rendering the graphics in your video games, it's powering the AI on your phone, it's running huge scientific simulations. It's a fundamental building block. But it can also be a massive bottleneck, slowing everything down. All right, let's get into what this actually is. So what is matrix multiplication? I promise it's not as intimidating as it sounds. And if you can get this one concept, you'll understand exactly why what AlphaTensor did is such a massive deal. Okay, just imagine you've got two grids of numbers. Let's call them matrices. You have a blue one and a red one. To multiply them, you combine their numbers in a very specific dance to create a totally new third grid. A really good way to picture it is like you have two sets of building instructions. You have to follow both of them to get your final product. The real puzzle isn't whether you can do it. You can. The puzzle is finding the absolute fastest way, the recipe with the fewest possible steps. And that's the heart of the problem. On one side, you've got the standard method they teach you in school. It's simple to follow, but it's brute force. It takes a lot of individual multiplications. But on the other side, there are these clever shortcuts, more elegant algorithms that get you the same answer with way fewer steps. And when your computer is doing this billions of times, finding a shortcut that saves even a few steps, that's a huge, huge win for speed.
Now, this is where things get really interesting. To find these shortcuts, mathematicians did something brilliant. They completely reframed the problem. They realized that finding the fastest way to multiply two-dimensional grids was actually the same as solving a mind-bending puzzle in 3 dimensions.
Right, so this puzzle uses something called a tensor. Don't let the word scare you. It's just a fancy name for a grid of numbers in 3D or even more dimensions. In finding the fastest algorithm, that's the same as decomposing the tensor. The best analogy really is a Rubik's Cube. The scrambled-up cube is your multiplication problem. Solving it means finding the moves to break it down into its simplest core pieces. The fewer pieces you can break it into, the faster your algorithm is. And to really get just how hard this puzzle is, you have to read this quote from the researchers themselves. They call the problem NP-hard. Now that's a technical term, but it basically means the problem is so ridiculously complex that you could never, ever check all the possible answers. The number of combinations is just too enormous. Get this, the search space is so vast that even today we still don't officially know the absolute fastest way to multiply two simple 3x3 grids of numbers. A problem this big, this complex, it needs a new kind of mind. So enter the hero of our story, AlphaTensor. It's an AI from DeepMind, built on the same ideas as AlphaGo, the famous program that mastered the ancient game of Go. The folks at DeepMind did something amazing. They turned this super abstract math puzzle into a single-player game. They call it TensorGame. So the AI is given the 3D tensor puzzle. At every turn, it makes a move. It decides how to combine some numbers. Then, the game gives it a score based on how many steps it's taking. The goal is super simple. Win the game by finding a correct solution with the lowest possible score. It wasn't told how to do it, it just played and played and learned how to win. And just to give you a sense of how hard this game is, for any single move, AlphaTensor has to choose from over 1 trillion possibilities. That's a 1 with 12 zeros after it. The number of choices is so astronomical, it makes the strategy in games like chess or Go look like tic-tac-toe. A human could never, ever navigate a space that large. And that brings us to the moment we've been building to. Because after playing this impossibly difficult game, AlphaTensor didn't just rediscover the solutions that humans had found, it started finding things that were completely new, things that were better. This timeline really says it all. Way back in 1969, a mathematician named Volker Strassen found a groundbreaking new algorithm. For over 50 years, his method was the fastest known for some key matrix sizes. Decades passed. People tried, but for these specific cases, no one could beat Strassen's record. And then, in 2022, AlphaTensor did what 5 decades of human ingenuity couldn't. And here it is, plain and simple. For multiplying 2 4x4 matrices, Strassen's famous algorithm took 49 multiplications. As you can see, AlphaTensor found a way to do the exact same thing in only 47. Now, shaving off 2 steps might not sound like much, but when you're breaking a record that has stood for half a century, that's a historic breakthrough. So, okay, who cares? It's a neat trick, but why does it really matter? Well, because what AlphaTensor did wasn't just finding one new shortcut. It showed us a completely new way to discover algorithms. This is really where the true power is. AlphaTensor didn't just find one algorithm, it found thousands of new ones for all sorts of different matrix sizes. It showed us that this whole world of algorithms was way more vast and interesting than we ever knew. And here's the kicker. You can tell it to find the best algorithm for a specific piece of hardware, like Google's specialized AI chips, and when you do that, it makes those chips run 10 to 20% faster. This isn't just a solution, it's a machine that builds better solutions. And that leaves us with this final, mind-blowing thought. For 50 years, we thought we were basically at the limit. AlphaTensor proved us wrong. So if an AI can uncover new fundamental truths in mathematics, what's next? What other massive, unsolvable problems in science, from designing new medicines to modeling climate change, could a system like this help us crack? It feels like the game is just getting started.
Don't forget, like and share to spread AI knowledge.